Okay, good. Good evening, Harshit.
Good evening, sir.
Good evening, Pranav. Pranav, good evening. So we had completed the force and laws of motion, right? And we have done some of the questions also based on that. Today also I would like to do questions from that, and then we can do, I think with chemistry, we were doing the first chapter. We are doing first chapter from chemistry, right? So we have done first chapter also from chemistry. We have done two chapters from physics. Okay. So we can start with the next chapter from chemistry. That's also there. So Harshit, shall we start with the next chapter from chemistry? Chapter 1 has been already done. The next chapter is matter around us pure. So we have here some of the questions. Is matter around us pure?
So aren't we
first,
doing bio?
yeah.
Sir, aren't we doing bio?
No, bio we are not going to do today. Today we'll be doing. See, we are not going like physics, chemistry, bio. We are going chapter wise. So once we start a chapter, we finish that chapter. Okay. Then we take up
Okay.
another chapter. Yes.
Okay, sir.
So once we start with, I think after this we'll be starting one chapter with bio. Okay. So in bio, I don't think that there are too many chapters. There are, I think, only 2, 3 chapters are there.
Yes.
Okay. So first chapter is your cell. Then you have your tissues, and after that there is only one chapter. I think uh, health health chapter is there.
Sir,
There is only,
improvement in food resources.
yeah, improvement in food resource. That's the only chapter. Health is also not there. So these are the 3 chapters only. So that's why bio will be taking at the end. Or we finish 2 chapters of physics, 2 of chemistry. Then we'll start with one chapter of bio. All right.
Okay,
So
sir.
since this is the revision plan, and in the revision plan we are going like that. Let's see. So I think almost everyone has joined. We can start now. So we have. Let's first try to understand this chapter. We have is matter around us pure? This chapter we are going to revise. Is matter around us pure? So whatever matter we see around us, the matter can be divided whether it is a pure substance or it is a mixture substance. So the pure substances are the substances. Pure substances are the substances which have all the particles of the where all the particles are similar in their size, shape, and mass. So such particles are the similar. If all the particles are similar to each other, we call it as a pure substance. And if all the particles are not similar, then we call it as a mixture. Got it? Okay, so is water a pure substance or a mixture?
Sir, it's a mixture.
Water, if I have H2O water, so is it a mixture or is it a pure substance? Suppose we have distilled water. Yeah, Rachit,
Yes, sir, it's a mixture.
mixture. Okay, Niharika.
Mixture, sir.
Okay, what are the components that are mixed in which have formed water?
Hydrogen
Hydrogen.
and oxygen.
Okay, see. So this is a wrong concept that water is not a mixture. Water is a pure substance. It's not a mixture. Okay, see how. Water is made up of water molecules, H2O. And all the water molecules, they are similar to each other. Got it? Is there any molecule which is different from the other? No. So water is not a mixture. Water is a pure substance. Got it?
Yes, sir.
Okay. See, suppose it's like, don't go with that chemistry what you have studied. Okay, suppose I take 10 apples in a basket. Okay, and there are only apples in that basket. So I will say that that basket contains pure substances. Okay, as it contains apples, all of them are apples, and all of them they are similar in their size and shape. So it's a pure substance. And if in along with that apple, if in that apple suppose there is a mixture of some other particles also. Right? Just 1 minute. Okay. All right. So we have pure substances and mixtures. Now, so I hope you have understood about the pure substances. What about if I mix water and common salt? So will the water remain pure or a mixture? If I add common salt to water, so what will happen?
Sir, it will become mixture.
Yeah, it will become mixture. Got it? Earlier it was pure, and if you add salt to it, it becomes a mixture. Now, see here, the pure substances, they can be either elements or compounds. Okay. So if they are elements, they can be either metals, they can be non-metals, or they can be metalloids. If they are compounds, so they can be either ionic compounds or they can be either covalent compounds. There are different types of compounds which can be there, okay, which are beyond the scope of your class. So you just see that pure substances, they can be either elements or compounds. We say elements, they are the purest form of matter, and they can be either metals, non-metals, or metalloids. Okay, now about the mixtures. So whatever mixtures you have, mixtures can be of two types, homogeneous or heterogeneous. So homogeneous mixtures they are also called as true solutions, okay, or they are simply called as solutions. So but in this characteristics of the homogeneous solution is that the particles are very small and they cannot be seen with the naked eye. Also, they do not show the phenomena of uh, Tyndall effect. So true solutions, they do not show the phenomena of Tyndall effect because the particles are very small. Got it? So the particles are very small, and that is why they do not scatter the beam of light. But colloids and suspensions, in both of them, the particles are big enough to scatter the beam of light, and therefore they make the path of light visible. So Tyndall effect is possible for both colloids as well as suspensions. Got it? Both colloids and suspensions can show the Tyndall effect. In suspensions, the particles are visible, but in colloids, the particles are not visible. The particles are small, but they are not that small. They are somewhere in between the true solutions and suspension. Mhm. I have explained almost everything. So pure substances consist of single type of particle, while mixtures contain two or more different types of particles. Pure substances, they can be either elements or compounds. So a pure substance that cannot be broken down into simpler substances by chemical means. Example, oxygen, gold, iron, they are the pure substances. They cannot be broken down by chemical means. You can't break down oxygen, you can't break down gold into still simpler ones. That are not possible. Okay, so they are elements. Compounds, they are pure substance composed of two or more elements chemically combined in a fixed proportion. For example, water, carbon dioxide. Then all these we have been homogeneous, heterogeneous solutions. Okay, one you get here. When you are studying about the solution, you know what is a solute and what is a solvent. A solute is the component of a solution that is dissolved. Or you can say, if it is solid and liquid, then the solid part is the solute and the liquid part is the solvent. Okay. So the solid part is the solute and the liquid component which is there, that we call as the solvent. Generally, the solvent is present in higher amount. Now, concentration. Here we see, we also know the strength of a solution, how strong the solution is. For example, if you are making a lemonade, so you definitely know how much of the sugar to be added. You don't add too much of the sugar. So that quantity we measure by the concentration. How much of the solute to be added, we call it as the concentration, or how much of the solute has been added. Okay. So this concentration can be represented in two ways. Either it can be written in gram per liter, okay, or it can be written as a volume by volume. It can be mass by mass also. It can be mass by volume also, or it can be in terms of molarity. Okay. Can anyone give me what is the formula to find out the concentration? Mass by mass.
Sir,
Anyone who
mass
can give me
of
the formula?
mass
Yeah.
of solid by total mass of solution into 100.
Yeah, mass of solute over total mass of the solution multiplied by the 100. And the total mass of solution is given by mass of solute plus mass of solvent. Okay, that gives the total mass. Then, okay, so what will be the answer for this? If 10 gram of sugar is dissolved in 100 gram of water, okay, so if 10 gram of sugar is dissolved in 100 gram of water, what is the concentration of sugar?
Sir,
Is
so
any?
10 by 100 into 100.
No, it's not 10 by 100. When you add 10 gram of sugar to water, the mass of the solution becomes 110.
110.
Oh, okay. So 10 by 110 into 100.
Yeah. So colloids and suspension. Colloids are the substances where the particles are very small of. The particles are they are bigger than the suspensions, but uh, they are bigger than the solutions, but they are smaller than the colloids. For example, long chain of carbon compounds like proteins, okay, like the micelles of soap or the soap solution. So such particles, they are not big enough that they can be seen with the naked eye. We cannot see the colloidal particles with the naked eyes, but still they are big enough. They can pass out through the filter paper. Okay, but the effect is that they scatter the beam of light. So they are colloids, mixture where the particle size is intermediate between the two solutions and suspensions. The particles do not settle out on standing and cannot be separated by filtration. For example, milk, fog, jelly, these are colloids. Then properties of colloids, Tyndall effect and Brownian motion. What is Brownian motion? Can anyone tell what is Brownian motion? No one? The Brownian motion, it is the zigzag motion of pollen grains or tiny particles or random motion of the tiny particles which are present on the in a liquid. It shows that they are particles of a colloid, they are in continuous motion. So random movement of colloidal particles which prevents them from settling down is called as the Brownian motion. So you have these differences between compounds and mixtures. Here is the difference between true solutions, colloids and suspension. Anyone has any doubt between these true solutions, colloids and suspensions? You can remember this particle size for them. For example, for the true solution, the particle size is less than 10 to the power minus 9 meter, which we call as a nanometer. Okay. For the true solution, the particle size is less than a nanometer, whereas for the colloidal particles, the size of the particles is between a nanometer and a micrometer. For the suspension, the size of the particles is greater than a micrometer. Micro means 10 to the power minus 6. For both true solutions and colloids, the particles cannot be seen with the naked eye. For the suspension, the particles can be seen. So, true solutions, they are homogeneous mixtures. The colloids, they seem to be homogeneous but actually are heterogeneous. So, the particles are not similar to each other. They seem homogeneous but they are heterogeneous. And suspensions, of course, they are heterogeneous mixtures. Now, true solutions, particles cannot be separated by filtration. Colloid also cannot be separated by filtration, but for the suspension, we can separate the particles by the filtration method. If you test the visibility, the true solutions, they are transparent. Colloidal solutions, they are translucent, whereas the suspensions, they are opaque. Then which ones are unstable, which ones are stable? So obviously you'll find homogeneous solutions and colloids to be stable, whereas suspensions to be unstable. Which of them will show the Tyndall effect? Pranav?
Yes, sir.
Out of the three, which ones will show Tyndall effect? Will it be shown by two solutions or colloids or suspensions? Which one will show
Colloids,
the
sir.
Tyndall effect? Colloids. What about suspensions? Do they also show Tyndall effect? Varun? 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 I hope you are not there. Harshit? Harshit, are you there? So, Harshit, Varun, if you are there and if you can hear me, just message in the chat box. Okay, message over here in the chat box. So, Harshit, Varun, Niharika?
Yes, sir.
Okay. So, do suspensions show Tyndall effect? See, in suspensions, the particles are big
Yes,
enough to
that's
scatter the beam of light. Okay, so they show the Tyndall effect. They show Tyndall effect. Okay, so both colloids and suspensions, they show Tyndall effect, whereas the others, like the two solutions, are unable to show Tyndall effect as the particles are very small. Examples, you should know for examples for all of them. Sugar in water, milk, blood. Sugar is sugar in water is a true solution. Milk and blood, they are colloids, whereas sand and mud in water, they are suspensions. Okay, types of colloids. Here there are different types of colloids. Liquid in gas, they are called as aerosols. A solution of air, liquid in gas, they are called aerosols. Okay. Examples are fog and cloud. They are examples of colloids. Okay. So see, you have a dispersed phase and the dispersion medium. The dispersed phase is called as the solute, and the dispersion medium is called as the solvent. So whenever we are making a colloidal solution, for making the colloidal solution, we take a solute and a solvent. The solute that we take, it's called as a dispersed phase and dispersion medium. Alright. So when liquid is taken as a solute in gas, they are aerosols. So an example of aerosols, you can say fog, clouds, your deodorants, heat that we use as a mosquito or insect repeller. They are examples of aerosols. Then you have when you take solid in gas. So solid in gas, this is also a type of colloid. Colloid. It is also an aerosol. So its example is smoke. Smoke contains tiny particles of carbon which are dispersed in air. So smoke is an example of an aerosol, which is a colloid. Then you have gas in liquid, which is foam. You have liquid in liquid that we call as emulsions, like milk, face cream, emulsion paint. They are emulsions. Solid in liquid, they are called as soaps. Solid in liquid, that is a soap, for example, mud, Diazine, they are solid in liquid. If you have gas in solid, that is a foam. Got it? Now we see some of the questions. We start with the questions of this. Okay. Which of the following is a pure substance?
Water.
Okay, water is a pure substance, all right? Okay, here we see steel is also written. Can anyone tell me what is steel a mixture of? Yes, what is steel a mixture of?
Sir, iron.
The steel is a mixture of iron and carbon. Remember, it's a mixture of iron and carbon. Okay, it may contain 40 to 60% of carbon. So steel is a mixture of carbon and iron. It's not pure iron. Which of the following is not a property of a solution? When we say solution, it means true solution. Okay. So which of the following is not a property of solution? Oh, sorry. Yes. All right, Sri. It is the solute particles which not a property of solution, that is solute particles can be seen by the naked eye. For the true solutions, we cannot see the solute particles by the naked eye, and therefore this is the correct option. Which of the following is a heterogeneous mixture?
Sir, oil and water.
Oil
Oil
in
and
water.
water.
Oil in water is a heterogeneous mixture, right? What is the term used for scattering of light by colloidal solution?
Tyndall effect.
Tyndall effect.
Yeah, it's Tyndall effect. In a salt solution, salt is the, what do we call the salt? Solute, solvent,
Solute.
Solute, sir.
yeah, it's the solute. A suspension is characterized by
B. Particles that do not settle down when left undisturbed.
no. A suspension is unstable. So when you leave, the particles do settle down at the bottom if are left undisturbed. Okay. So that's not correct
Particles
one.
that form a true solution.
Particles that form a true solution, that's also incorrect. Okay. So particles that are invisible to the naked eye, that is also incorrect. Particles that do not settle down when left undisturbed, this is also incorrect. They do settle down. Particles that scatter a beam of light. So obviously suspensions scatter the beam of light. Tyndall effect is shown by colloids as well as suspensions. Okay. So its correct option is option C. Now, which of the following is not a compound? Water, carbon dioxide, iron, and sodium chloride. Which of them is not a compound?
Iron.
Yeah, iron is not a compound. Very good. Which of the following is an example of pure substance? Brass, bronze, oxygen gas, seawater.
Oxygen gas.
Okay. Oxygen gas. Brass is a mixture. Okay. Brass and bronze both are mixtures. So can you tell me what does a brass consist of? What are substances are used for making brass? So brass is a mixture of copper and zinc. Right. And what is bronze a mixture of? What does a bronze consist of?
Copper.
Copper and
And tin.
okay, bronze is a mixture of copper and tin. Alright. Whereas brass is a mixture of copper and zinc. Sea water is a mixture of water and salts. So oxygen gas. Which of the following statements is true about a homogeneous mixture?
C, sir.
For a homogeneous mixture, the components are easily distinguishable. No. The components are uniformly distributed. Yes. For a homogeneous mixture, the components are uniformly distributed. That is correct. Okay. If you say the components can be separated by filtration, that's not possible for homogeneous mixture. It always contains water. That's also not correct. It can be an alcohol solution also. It can be an acetic acid solution. Okay. It's not necessary that it should contain water always. Then what is main difference? So the correct option here is option B. All right. Next is what is the main difference between suspension and a colloid? Varun, are you there?
Yes, sir.
Okay, so where had you gone?
Sir.
Yeah, you had gone somewhere. You are not responding.
Oh, sorry, sir.
Earlier when I asked, you were not responding.
Oh,
See,
sorry,
I
sir.
messaged.
My earphones just switched off.
Even if the earphone switched off, it's not the problem. You are not. I gave you another option. Okay, so be there in
Uh,
class. Okay,
Sorry,
don't
sir.
leave the class.
Sorry, sir.
Okay. So the difference. What is the main difference between a suspension and a colloid?
So the particles are suspended in a suspension. It is not uniformly mixed, sir. But in a colloid, it's uniformly mixed, sir.
Okay. So out of the given options, see particle size,
Oh,
type of solvent,
sir,
type of
particle
solute.
size.
Hmm?
Sir, particle size.
Particle size. Yes, it's the particle size. Then which of the following is a solution?
Salt water. Salt water.
Okay, salt water is a solution. Okay. Milk is a colloid. What about muddy water?
Sir, it's a mixture.
It's a suspension. Of course, all of them are mixtures. So which of them, which type of mixtures we do? Milk is a colloid. Muddy water is a suspension. Salt water is a solution. Smoke is, what about smoke? Is it a suspension or a colloid?
Sir, colloid.
Colloid. Colloid. Which of the following is the characteristics of mixture? Do they have fixed melting and boiling points? Or do they have components retain their individual properties, always homogeneous or chemically combined?
Sir, is it option C?
Yeah, options are there A, B, C, D. Question 12.
Yes, sir. Is it option C?
Always homogeneous. No, mixtures can be either homogeneous or can be heterogeneous.
Sir, is it D?
That's incorrect. They're not chemically combined. Mixtures are never chemically combined. That's also incorrect.
Sir,
The
B.
correct option is option B. Components retain their individual properties. Okay, so if you're forming a solution of two substances, so their properties are still there. They have not lost their properties. For example, there was an exercise in your book, I think regarding sulfur. Yeah. You take some iron filings and sulfur powder, you mix them. So even after that, if you bring a magnet near that, it will attract. it will attract the pieces of iron. That means it has its property. Its property has not been lost. But if you heat that, by heating it forms a chemical which is iron sulfide. So when it forms the chemical, then that means it has lost its property. And if you take up the magnet, it will no longer stick to it. Okay. So components retain their properties, individual properties. Okay. What kind of mixture is blood?
So heterogeneous.
Okay, blood is a heterogeneous mixture. Very good. Is blood a suspension or a colloid or a true solution? Yes. What kind of mixture is blood? See, blood is a colloid. The blood consists of a number of proteins which are floating through it. Okay. So blood is a colloid. It's a colloid, and therefore we know that colloids are heterogeneous mixtures. They are not homogeneous mixtures. They appear to be homogeneous, but they are not homogeneous. Okay. So blood is a heterogeneous mixture. Okay. The particle size in a colloid is. Yeah. Now this is a important question. See, what is the particle size in a colloid?
So larger than 100 nanometers.
Larger than 100 nanometer is incorrect. If you say larger than 100 nanometer, so then it can be 1 millimeter also. Okay, so 1 millimeter is the size of 1 millimeter is the size of this, what we call suspensions. Less than 1 nanometer, no. Less than 1 nanometer is true solution. Okay, between 1 nanometer and 100 nanometer, this is correct one. The next is does not affect the state of the colloid. Which of them does not affect the state of the colloid? The correct answer here is C. Now move on to the 15th one. Which one of the following is not a property of a compound? It has a definite composition. It can be separated into its components by physical methods. It has properties different from its constituent elements. It is a pure substance. Yeah, everyone. Harshit? Harshit?
Sir, is brass an alloy?
Yes, sir.
So which one of the following is not a property of a compound? The first option is it has a definite composition. So do the compounds have a definite composition? Yes or no?
Yes, sir.
Compounds do have a definite composition. Okay. So compounds do have a definite composition. Okay. Then which of the following is not a property of a compound? It has a definite composition, that is, it can be separated into its components by physical methods. Obviously, this is incorrect. You cannot separate the components of a compound by physical methods like
Sir, is it
filtration.
option C?
No, it's option B. It cannot be separated into its components. Okay, it can be separated into its components by physical methods. So this is not a property. Correct option will be B. B is the correct one.
Okay.
Okay. If you say C is the property of the compound, so we cannot include it to be not a property. Which of the following is a mixture of elements only? A mixture of elements only.
Sir, brass.
Yes.
Sir,
Brass.
brass is alloy, right, sir?
Yeah, so it's an alloy of only elements. There are no compounds there.
Okay, sir.
Okay, so that is correct.
Sir,
Option is
what about
brass.
water?
Water is not a mixture at all. It's a compound. Okay, so you have to identify a mixture that is, and in that mixture, it should be made up of only elements. So air is a mixture of elements as well as compounds. Chalk is a mixture also, but it is not of elements only. It is of compound. Brass is a mixture of copper and zinc. So it is a mixture of elements only two elements. Next one is, which of the following applications does not depend on water as the solvent?
Sir, making cooking oil.
Mm, Making alcoholic drinks, making cooking oil, yes. Making cooking oil does not depend on water as the solvent. Okay, the cooking oil does not contain water as solvent. Now, a mixture can be classified as solution, colloids, and suspensions. Which of the following methods will not allow you to distinguish between a solution? Okay, which property will not allow you to distinguish between a solution?
Sir, is it D?
Yeah, D, heat the mixture. Okay, it won't let you know about the solution. Okay. Now here we have some of the assertion and region questions. Just go through the directions that are given here first. Right. Your directions are, you have to choose option A if both assertion and region are correct, and region is the correct explanation of assertion. You can choose option B if both A and R are true, but R is not the correct explanation of A. You can choose option C, which is A is true but R is false, and you can choose option D if you say A is false but R is true. Alright. So see the first question. You have an assertion given. A solution of salt in water is a homogeneous mixture.
Sir, A is false, R is true.
A is false. A solution of salt in water is a homogeneous mixture. Is it false or true?
Sorry, sir, true.
Okay, assertion is true. Okay, now we'll check the region. So region given here is the components of homogeneous mixture are uniformly distributed. So obviously, first of all, we see it. So it is a correct statement. And now we combine the two and let's see is the first one a explanation of the second one. Okay. So you have the components of homogeneous mixture, they are uniformly distributed, and this is correct. Okay. So assertion is correct, region is correct. Now we check whether region is the correct explanation of assertion or not. Okay. So is the region correct explanation of the assertion? Yes, it is the correct explanation also. So we choose here option A. Now see, air is a mixture. So it is correct, it is true. Now we see the region. Air can be separated into its components by physical methods like fractional distillation. Yes, this
So,
is also this is also
so air
correct.
can be
And
separated in its components.
yeah, air can be separated into its component by physical methods of fractional distillation. Okay. So in a distillation tower, by using fractional distillation, you can separate all the gases. You can separate hydrogen, oxygen, carbon dioxide. All the gases can be separated out.
So both A and Q and R is not the correct explanation of A.
R is the
Okay.
correct explanation. That is why we
Sir,
call air as a mixture. As the particles can be separated into its component by physical methods. That is why we are calling it as a mixture. If we could not separate it by this, so we won't call it as a mixture. So it is the correct explanation for 2 also. Okay, for 3, milk is a colloid, and reason is colloids are heterogeneous mixtures in which the particle size is between those in two solutions and suspensions. Okay, so the region is also correct. All right. The next, when a beam of light is passed through a colloidal solution, its path becomes visible. Okay. So when a beam of light is passed through colloidal solution, its path becomes visible. This is true. Colloids show the Tyndall effect. So this is true. Then reason is light do not get scattered by colloidal particles. Okay. So this is incorrect. Light does get scattered by the colloidal particles. So reason is incorrect, but assertion is correct. So this is option C. Assertion is true, but reason is false. Next is milk is an aerosol. So is the assertion correct?
sir, no.
No. Milk is not an aerosol. It's milk contains, so assertion is incorrect. So this will be option D. Assertion is incorrect. Assertion is false. Okay, what is a pure substance? Okay, just define what is a pure substance.
Where
A
particles are uniformly distributed in the solution. In
No, not
substance.
uniform. All the particles, they are similar to each other in their mass, size, and chemical properties. So we call them to be a pure substance. A pure substance is a material that has constant composition and has consistent properties throughout the sample. For
So,
example, gold. Yes. Okay. Then define a mixture and give 2 examples.
so
So
pure
Shravan
substance
will
is
do.
made up of only. Sir, so pure substance is made up of only one type of particle.
Yeah, only one type of particles. It doesn't mean that only one element. One type of particles. That means all the particles of which it is made, all the particles should be similar in their size. They will be similar in their masses. Okay. Got it? Okay, any doubt? Are you having any doubt relating to carbon
No, sir.
dioxide or anything? Okay. So, for example, if you see a carbon dioxide, so carbon dioxide, it is a pure substance, as it can have it's made up of only one type of particles, which is carbon dioxide. So there will be everywhere carbon dioxide molecules of which it is made. Define a mixture and give 2 examples. Okay, can you define a mixture and give two examples? Okay. See, a mixture is a substance. A mixture is a combination of two or more substances, where each substance retains its chemical properties. So the substance retains its chemical properties. We call it as a mixture. All right. Okay, so we have these questions. I think you can just go through these questions. With this, we have completed this chapter. So today we started this chapter from chemistry and we have completed a revision of it. So you can go through these questions if you want. There are some long answer questions also, but generally nowadays these such type of questions are not asked. You have questions regarding knowledge based and competency based questions. See this competency based question here you have. You can try to do this. You are given a sample of water from a river and a sample of distilled water. How would you determine which one is pure substance and which one is a mixture? Yeah, which now Niharika will. Niharika?
Yes, sir.
Okay, how can we say, what reasoning will we give?
So, sir, you can look at it like if the particles are big enough in the mixture, you can see if it's a mixture or not. If it's
Yeah.
not like that, then you can you can see which ones like elements are closer together, like similar, more similar.
Okay, all right. Okay, so I think you can, first of
Sir,
all,
I
you
think
can
the
you can
distilled water is
observe this.
purified.
Yeah.
Sir, I think distilled water is
Yeah, distilled water is not a mixture, whereas a river water is a mixture. Okay, this can be shown by observation. Either you observe it, you will be able to see some particles settling down. Okay, so one step is observation, then you can test for the Tyndall effect also. You can check for filtration also. All right. Okay, bye everyone. Good night and see you all in next class.
thank you, sir.
Thank you, sir.
Thank